Please give screen sharing, please. Dear team, please give the screen sharing. Hello team, please give the sharing, please. Am I visible? Good afternoon. Am I audible? Hello. Hello. Am I audible? Excuse me. Can anyone please reply? Am I audible?
Yes, sir.
Audible? Okay. My voice is clear. My screen is visible to you.
Yes, sir. Yes, sir.
All right. Carry on. Yes. In the previous class, we have discussed about the what are the pericyclic reactions and the classification of pericyclic reactions and the stereochemistry of electrocyclic reaction and the part of the stereochemistry of cycloaddition reactions are discussed. In continuation to that, the first mode we have discussed, that is okay, four modes are possible. The cycloadditions are undergoing four stereochemical modes. One is the supra-supra, and second one is the supra-antra, and antra-supra is the third one, and the fourth one is antra-antra. How we are classifying this supra-supra, supra-antra, antra-supra, and antra-antra? In the electrocyclic reaction, what we have discussed, the stereochemistry, suppose the electrocyclic reactions are only one reactant is involved in the reaction, that may be undergo the overlapping of these terminal carbons by overlapping of p orbitals. Either may it is undergoing both are in clockwise, both are in anti-clockwise. That is known as con electrocyclization or con rotatory electrocyclization. Con rotatory electrocyclizations. And if one is clockwise and other one is anti-clockwise or vice versa, it means if it is anti-clockwise, it is the clockwise. This is known as disrotatory electrocyclization. Similar, in the entire reaction, we have observed only one substrate is involved in the reaction. Similarly, whenever we are classifying the uh, stereochemistry of cycloaddition reactions, we need to consider individual substance stereochemistry. Individual substance stereochemistry. For example, in the cycloaddition reaction, in the cycloaddition reaction, just a minute. In cycloaddition reaction, two five components are involved in the addition. Two five components are involved in the addition. So, for example, this is the first phi system with two pi electrons. This is the second phi system with two pi electrons. Okay. Now, whenever we are classifying this reaction stereochemistry, we need to consider individual pi component. First, I am considering this pi component. This pi component is producing the two sigma bonds with the second pi component by involving either this lobe may be involved in the one interaction, or this may be involved, or this may be involved, or this may be involved. Therefore, we have four choices are there, four options are there. That is the reason this pi substance may be undergo, for example, the same side lobes. These two lobes are interacting. For example, these two are undergoing producing this interaction for the bonding interaction. For bonding, it is participating in the interaction. In the bonding interactions, these two lobes are maybe involved. These two lobes are within the same phase. Both are in same phase. Or we are called it as same phase. These are called same phase. Such kind of interactions are known as supra interaction. Or very in the full form we call it as suprafacial interaction. Right. And other alternatives, the same phi component may be participating with these two lobes, or also the suprafacial interaction. These two lobes are also involved in the intra-bonding interaction with these same side lobes. Suppose this pi system is maybe undergoing this kind of interactions are known as suprafacial interaction. Okay, for example, the same phi system may involve in the other interactions. Like if you take this phi system, the same phi system, one of the interaction is achieved from here. That means that this is the lobe involved in the from the orbital. Next, the second interaction may be achieved from here, or other alternative, the same phi system, the orbital which is involved in the bonding interaction. In that bonding interaction, this lobe is involved in the from this side. The lobe is involved here, and the second interaction may be here. Look at here, the interacting lobes are in opposite. The interacting lobes are opposite. This is known as anterofacial interaction. Anterofacial interaction or andra interaction. Got it as andra interaction. Right. Now, when you combine two five molecules in the cycle addition, when you combine two five molecules in the cycle addition, suppose the cycle addition is 2 plus 2 cycle addition, 2 plus 2 cycle addition. In this, these two phi systems are involved. In this first stereochemistry is supra addition. Supra addition. In this supra addition, with respect to the first phi system is supra, with respect to second phi system is supra. Now for that purpose, I am making this is the one of the bonding interaction. You make it standard, and the second interactions in the between the two phi systems, one is from here and other one is from here. Right? You hide the second phi system. First you hide this one. You hide this one. You just consider within this phi system the interacting lobes are same side or opposite side. These two lobes are same side. Therefore, with respect to this phi system is supra. Now coming to here, second phi system. In the second phi system also interacting lobes are on same side. Interacting lobes are same side. This is one. This is also called suprafacial interaction. Next, second stereochemical. Supra antra. In this supra antra, with respect to the first phi system is supra, with respect to second phi system is antra. Now, the two lobes of the phi systems are approaching like this. You keep this interaction as standard, right? With respect to the first phi system is supra. Therefore, this lobe is participating in the interaction. And with respect to the second phi system is antra. Therefore, opposite lobes may be. Already this lobe is involved in the interaction. The second interaction may be achieved from here. Therefore, the second bonding interaction is achieved like this. Now, with this one, with respect to the first phi system, this is the supra interaction. With respect to the second phi system, this is the antra interaction. Right. Coming to the third. Now here, this interaction, supra antra interaction also, this orientation is called linear approach. If it is also explained in orthogonal approach. It is explained in the orthogonal approach. How it is explained? Look at here. Here I am considering. Suppose this orbital is of the phi system orientation of the orbitals is like this. You are watching like this. Suppose I am rotating this orbital into 90 degrees. I am rotating this one is 90 degrees. Whenever you are rotating 90 degrees, here previously these orbitals are oriented like vertical manner. Once you are rotated 90 degrees, that this will be those are will be oriented in the horizontal manner like this. Suppose if you are watching this orbital system in the front side, what you see that only the circle, the front lobe maybe you can watch it. The front lobe you may be observe it. This is the first phase system. And the second phase system is oriented in the orthogonal approach like this. It will be non-linear approach. Now, with respect to the first phase, these two lobes are participating in the interaction. That the same side lobes are participating in the interaction. Therefore, these two lobes are on the same side. With respect to the second phase system, opposite lobes are interacting. Now, you make it. This interaction is standard interaction. You make it one interaction should be standard interaction. That means this interaction is taken as standard interaction, and the second interaction is linear. With respect to this system, it is supra. With respect to this second phase system, these opposite lobes are interacting in interaction, bonding interaction. Therefore, this is antera. Okay. Now, coming to third bonding interaction, that is third stereochemical mode, that is antera supra. Antera supra addition. Now, first you are understand the linear approach. This is the first phase system, and this is the second phase system. You keep one interaction is standard for understanding or uniform results. The second interaction with respect to the first phase system is andra. Therefore, opposite lobe may be interacting. Therefore, this lobe is involved in the interaction. With respect to second phase system is supra. Already this lobe is involved in the interaction. The second lobe which it is going to be interacted with is this lobe. Therefore, the interactions are like this. Now you can classify the phase system. First phase system is andra. With respect to the second phase system is supra. Whenever it is showing in the orthogonal approach, this one is linear approach. Linear approach, you can also call it as parallel approach. The second one, with respect to the first phase system, it is oriented as it is, but the second phase system, it is oriented as a that may be rotated and showing like this. That means we are observing only front lobe. The rear lobes are disappear. Now the interaction. What is that interaction? This is the standard interaction. What we've shown here, right? This is the interaction standard interaction we show. Next, the second interaction is like that. Now you can observe it in the first phase system. Interacting lobes are opposite phase. This is the topmost phase, this is the bottommost phase, or we can call it as a negative phase, this is the positive phase. Therefore, it is antra. With respect to the first phase system, it is antra. Here, the second phase system is both the lobes are on the same side. Therefore, with respect to the second phase system, this is supra. Okay, this is the third stereochemical mode. Now, coming to the fourth one, andra, andra. Now, first you observe in the linear approach. This is a standard interaction. The second interaction with respect to the first phase system is antra. Therefore, the opposite lobes are involved in the interaction. With respect to the first phase system, these two lobes are involved in the interaction. These two lobes are involved in the interaction. With respect to the second phase system is also antra. Therefore, the opposite lobes, these two lobes are, because already we maintain the one standard interaction. The second interaction should be changing the scenario. Therefore, these two lobes are involved in the interaction. Therefore, this is antra mode, and also the second phase system is also involved in the antra. Okay, whenever we are, this is linear approach. Linear approach. Whenever it is shown in orthogonal approach, this is the first phase system. It is shown like this, and The second phi system, the orientation is like this. We maintain the standard interaction. One interaction is here, and other interaction, the second interaction is here. In both the cases, this is antra. Two opposite lobes are involved in the second phi system. This is antra. In the first phi system, the opposite lobes are antra, and antra orientation of stereochemistry. Okay, we call it as stereochemical curves. Okay, now we can take one example. If we take one example, right. Here I am going to take one of the molecule. Yes. Generally, the double bond attached double bonds, whenever it is like this, a simple olefin, it is planar actually, planar. But I am whatever the plane I am showing like this. Actually, it is the whenever we are passing the plane and on a paper, that is the molecular plane. That molecular plane I am just rotating 90 degrees. That plane is lifting to rotating 90 degrees. Whenever we are rotating 90 degrees, the plane which is this is the molecular plane, and there is another plane we can see the paper plane is passing through like this. Only double bond. Whenever it is passing through double bond, this is the methyl group is above the plane. This methyl group is above the plane. The hydrogens are below the plane. Now we can observe that whenever we are placing this butene, two butene in that orientation, you see that the methyl groups are first and hydrogen groups are appear far away to you. Okay, that orientation I have considered here for explaining the stereochemistry of this 2 plus 2 cycle addition. Right. Just I want to remove this one. Okay. Right. Okay, we can keep this one is hydrogen here, and methyl group is above the plane. Similarly, you can orient another molecule also. Here also, just one over the other, I am keeping the two butene molecules. Okay, hydrogen. This is CH3, CH3. I am keeping the two molecules one over the other. Right. Whenever we are showing these molecules in the orbital representation, these orbitals are oriented perpendicular, actually perpendicular to the that line. And here the hydrogen is represented like this, and the methyl group is represented like this. Next, hydrogen CH3. Similar. You can take the second molecule. You can keep this somewhat larger. Okay. CH3, hydrogen and CH3. You have taken two molecules. Now, the first mode. The first stereochemical mode is just directly I am taking only transition state. Pi to S, pi to S, cycloaddition. Pi to S, pi to S, cycloaddition. Then pi to S, pi to S means both are suprafacient. With respect to the first stereochemical mode is supra. Yes. The one interaction you maintain here. The second interaction is like this. The interaction between the orbital. For this purpose, the interacting one over the other, for making the interactions, there is no bond rotations are required because both are undergoing supra mode operation. With respect to the first pi system is supra, with respect to the second pi system is also supra. Now, the molecule after the reaction it gives this is the CH3, this is the hydrogen, this is the CH3, this is the hydrogen, CH3 and hydrogen and hydrogen in the CH3. That means look at here, all the methyl groups are above. Therefore, all cis compound is generated. All cis. That is cis, 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 1 comma 2 comma 3 comma 4 tetramethyl cyclobutane is the product. Cyclobutane is the product. Similarly, you can come into the second stereochemical mode. If you observe the second stereochemical mode, second stereochemical mode is phi to S, that is supra, and antra, phi to A cyclidation, phi to S and phi to A cyclidation. You can see this here. Right. I'm keeping it. Okay. One interaction is like this. One interaction is the standard interaction. With respect to the first phi system is supra. Already this lobe is involved in the interaction from the first phi system. The second phi system is also same side with the first one. Therefore, this one is the second interaction shown by the carbon. Right. Next. Right. The second interaction from the second pi system is andra. Already this lobe is involved in the interaction. The second lobe should be opposite to the first one. Therefore, this lobe is involved in the interaction. The interactions, for your understanding, I am changing color. The interactions Just a minute. Right. The interactions like this. Right. Now this with respect to the first phi system, it is supra mode of interaction. With respect to the second phi system is it is andra operation. Then what is happening when andra for interacting with this low, this bond, this carbon carbon bond is undergoing what is happening? 180 degrees rotation. It leads to undergoes 180 degrees, sorry, 180 degrees rotation. This is undergoing 180 degrees rotation. Now, what is the product now? What is the product is generated here? We can observe the product is right. Here, these two places, this with respect to the first phi system, total supra. Therefore, the below group is hydrogen, the above group is always methyl group, right? With the paper plane. Now here, it is also involving in the same above lobe, but at the second carbon position, it is undergoing the below lobe. Bottommost lobe is involved in the interaction. For overlapping, it requires the bond rotation. Therefore, there is no change at this carbon stereochemistry, but the stereochemistry at this fourth carbon, it will be reversed. That means the hydrogen becomes moving to up, the hydrogen CH3 group is moving down. Now, what is the stereochemistry? Both are opposite. These two methyl groups are opposite. Therefore, that is trans. These two are same side. This is cis. These two are same side. Cis. These two are trans. Now the product is cis, trans, trans, 1 comma 2 comma 3 comma 4 tetramethyl tetramethyl cyclobutane. Tetramethyl cyclobutane is the product. Okay. Okay, these are the four stereochemical modes of phi 4 plus 2, phi 2 plus phi 2 cycloadditions. Phi 2 plus phi 2 cycloadditions. If we coming to the next higher one, phi 4 plus phi 2 cycloaddition. Phi 4 plus phi 2 cycloaddition. Then the starting materials, one with 4 pi electrons. Therefore, we are going to take 1 comma 3 butadiene, 1 comma 3 butadiene. This is a 4 pi electron system, and this is the 2 pi electron system, which are undergoing cycloaddition, and at the middle of the reaction, it generates a transition state. This is the transition state, right? After the formation of two sigma bonds, now it leads to the formation of this is cyclo butene. Sorry, cyclohexene is the product. Cyclohexene is the product. Cyclohexene is the product. Right. Now, how many stereochemical modes it can participate as per the previous observations? How many stereochemical modes it can participate? In all stereochemical reactions, stereochemistry of cycle addition reactions are shown in four modes. This is a 4-5 electron system. Now the interaction, these two lobes may be involved. From here, these two lobes may be involved. Right. Now, this the first stereochemical mode, 5,4s plus 5,2s cycloaddition. 5,4s and 5,2s cycloaddition. Right. Now, you can maintain the standard interaction here. With respect to the first pi system is supra, with respect to the second pi system is also supra. Now, in this first pi system, the bonding interactions are observed in the two lobes. Those two lobes are on the same side. Therefore, it is supra mode of addition. With respect to the second pi system, the two lobes are involved in the interactions. Those two lobes are on the same side. This is also supra mode of interaction. Okay, here I am going to give the one example. This is the hydrogen, this is the CH3, this is the CH3, this is the hydrogen, which is participating in the supra mode of addition. Example hydrogen, this is the CH3, hydrogen and the CH3. Now the interactions may be happening between these two and these two groups. Then the resulted product we can show like this. Right. These two hydrogens are far away to the observer. Okay. These two hydrogens are far away to the observer. Therefore, the bottommost groups are far away to the observer, and these methyl groups are upper groups. Therefore, there is no change in the stereochemistry while this is involved in the supra mode of addition. Therefore, it leads to the formation of cis product. It is involving in the formation of cis product. The remaining positions also we can show that CH3, hydrogen, CH3 and hydrogen. Just a minute of connection only. Both the inside groups are moving. Just a minute, please. CH3 and hydrogen. Now this is also leads to produce all cis products. Cis, cis, cis with numbering 1, 2, 3, 4, 5, and 6. Then the product is 2 comma 4 comma 5 comma 6 tetramethyl cyclohexene. Tetramethyl cyclohexene. Right. All this product is generated. Or we can also take the different way. I'm taking other example. Suppose the methyl group is outside the orientation. This is the CH3 is oriented here. You can take hydrogen is here, and hydrogen is here. The CH3 is here. Other orbitals. Next, olefin dienophile. You can take like this. This is the far away to the observer, far away to the observer. And whatever the group you are taking, I'm going to take nitrile group here. Nitrile group, the CN. Then it is involving in the one interaction, standard interaction. With respect to the first pi system is supra. With respect to the second pi system is also supra. Now both are oriented same stereochemistry, but after the cycle addition there is no change in the stereochemistry of at any carbon. Then the product leads to produce no change in the stereochemistry at any center, right? Oh, sorry, this is the six member ring, right. Six member ring is the product. Okay, this is the product. Now this is the above the plane. That methyl group, cyanide nitrile groups are here, and these two methyl groups are outside groups. These outside groups, whenever it is involving in interaction, they may undergo rotation like this. A small fraction of angle it will be rotated. Therefore, that methyl group is oriented bottom of the plane, and this methyl group is also oriented bottom of the plane. Right. Now, what is the product here? This is the cis, this is the trans, this is the trans. Now, the product is trans cis, trans product is observed. Trans cis, trans product is observed. Okay, right. Similarly, you can take the second stereochemical mode, 54A. You can take the second stereochemical mode is superactive. 54S plus 52A cycloaddition. Cycloaddition. You can name it as a supra-andra addition. 4 plus 2 supra-andra cycloaddition. Right. You can take the directly orbital structures. Right. You can maintain one interaction as standard interaction. With respect to the first pi system is supra. Therefore, those interacting lobes are on same side. These two lobes are involved in the interaction. With respect to the second pi system is andra. Already this lobe is involved in interaction. The second lobe must be opposite to the first one. Therefore, this is the interaction pattern. Now, you can take the example of this frame, this previous one. As it is, you can copy it. Here I'm going to paste it. Right. Right. Okay. Now the second interaction should be andra. Therefore, right, you can erase this one. Now the interaction with respect to the first phase system is supra. With respect to the second phase system is supra. This one is correct. Opposite same side lobes are involved in the interaction. With respect to the second phase system is antra. Now this one and this one both are involved in the interactions. Now you can mix up with the right. You can mix it. Show the interaction. This one is the interaction. Therefore, this one is not the supra. It is the antra. Andra mode of interaction. Andra mode of interaction. Then, right. Now the product is, you can look into here. A six-member ring it will be generated. Then this one at this position, this is the andra. Therefore, this CC bond needs to be undergoing rotation. Undergoing rotation. Therefore, at that position, the stereochemistry becomes inverted. Then the product is to this position. The methyl group is oriented to bottom. Here, the methyl group is also oriented to bottom. And here, the nitrile group, there is no change in this position. But here, the position of nitrile group becomes changed. Now, what is the product here? The trans. The all trans product is generated. Okay, just a minute. Okay, you want the same side on the right, right. This is the cis. No, sorry. Ah, trans trans cis product is generated. Trans cis product is generated. Then coming to the third stereochemical mode. Third stereochemical mode. Are you there? Anyone is no response from your side? Are you following?
Yes, sir.
Those who are joined today, it is very new. Okay. If already involved in the previous classes, it may be some sort you can understand it. But those who are only joined today, it may be difficult to understand. But follow this. Not a rocket science. You can easily understand it. Okay. Then coming to third stereochemical mode. 5,4A plus 5,2S cycle addition. 5,4A plus 5,2S cycle addition. Right. Here in the previous case, with respect to the first phase system is with respect to the phase system is Andra. With respect to the second phase system is Supra. Andra means opposite lobes are involved. One interaction is bottommost lobe is involved, and the second interaction should be opposite lobe. That is, the topmost lobe is involved in the interaction. With respect to the second phase system, both are Supra. Already this lobe is involved in interaction. The second lobe should be the same side. Therefore, the interaction is opposite lobes. With respect to the first phase system, it is Andra. With respect to the second phase system is Supra. Now, coming to the products, example and product. Here I am going to take this same product. Now, this is the example with respect to the first phase system is Andra, right? Right. Now, the interacting lobes, right? Andra mode of addition, therefore the opposite lobes are involved in interaction. That opposite lobes, this one is already involved in interaction. The opposite lobe is this one. With respect to the second phase system is Supra, therefore the same side lobe is involved in interaction. The interaction should be like this. Therefore, this is Andra, this is Supra. Once which is becomes the Andra, it is undergoing CC bond rotation. Therefore, at the center, the stereochemistry is changed. Stereochemistry is becomes change. Therefore, at the center, the graphic card is very becomes very slow. Right. Now, at the center, this is Supra. Therefore, at the center, there is no change in the stereochemistry. Therefore, nitrile is here, hydrogen is here, and the stereochemistry becomes previously it is in bottom, but after the CC bond rotation, it moves to up. Then what is the stereochemistry becomes here? What is the stereochemistry here? Again, cis, this also becomes cis, and this will be trans. Now the product is trans cis cis product is generated. Trans cis cis product is generated. Cis cis product is generated. Okay, this is the third stereochemical mode. Next, last one, 5,4A plus 5,2A cycle addition. 5,4A plus 5,2A cycle addition. Now we can take the this is the first pi system with 4 pi electrons. This is the second pi system with 2 pi electrons. Now it is both are antra-antram. You maintain the same standard interaction. The second interaction should be it is the bottommost lobe involved in the interaction, and the second lobe should be outer pole. Above a topmost lobe is involved in the interaction because it is antra mode of addition. With respect to the second phi system is also antra. Therefore, already this lobe is involved. The second lobe should be opposite to the first one. Therefore, these two lobes are involved in the interaction. Therefore, this one becomes antra because two lobes are opposite to each other. Therefore, antra with respect to the second phi system becomes also antra. Now, in your example, you consider the same example, right? Right. Then here it is and already involved. Therefore, you can delete it. You can delete it. Right. With respect to the first phi system, Antra. Okay, it is followed. The second one is also Antra. Therefore, the interaction like this, the interaction, the interactions are happening like this. This is already true. Both are opposite lobes are involved. And the second interaction in the second phi system, these two lobes are involved. Therefore, this is also Antra interaction. Now, at this center, both the centers, the stereochemistry becomes inverted. Already we are written, this one is this moving to above. Here, this becomes hydrogen, this becomes nitrogen. Now the stereochemistry becomes, this becomes the trans, this is also become trans, this also becomes trans. Therefore, the product is all trans product generated. All trans product is generated. After watching all these reactions, you can observe that the reactions, pericyclic reactions, are highly stereospecific. Why? Because highly stereospecific, we can see that each stereochemical mode produces different product with the others. One, for example, supra-supra mode of product is different from the antra-supra. Antra-supra is different from the antra-antra. Therefore, every stereochemical mode is different. Therefore, it produces the different specific stereoisomer is generated in the pericyclic reactions. Trans-trans supra-supra mode, click in here. Most of the cases, supra-supra and antra-antra products are matched, and antra-supra and supra-antra products are matched. But when we are taking the symmetrical substrate, suppose 2 plus 2 cycle additions, this may be happen. But in the case of 4 plus 2 cycle additions, the stereochemistry may be deviated in all stereochemical modes. Right? This is about the stereochemistry of cyclo addition reactions. Next, coming to the sigmatropic reactions. Coming to sigmatropic reactions. Stereochemistry of sigmatropic reactions. Sigmatropic reactions. Look at here. Here I am going to consider a general phi system. This is a phi system. The group or an atom which is migrating across the phi system from one position to the other position. One position to other position. Right? Now, after migration, suppose this one is I comma j shift. I comma j shift. That the G is shifting from this position. It is known as migration origin. Migration origin. From it is moving from migration origin to migration terminal. Migration migration terminal. Right. Now, suppose here the G is migrating here the two ways. Here it is attached in the bottom of the phi system. Therefore, after migration, it is also attached to the bottom. Or otherwise, after migration, the group is migrated to above to the previous place. Previously, it is existing bottom, down position. After migration, it reached to topmost position. Now, this migration is called as suprafacial migration. This migration is called anterofacial facial migration. What is the reference for expressing it is superfacial and anterofacial? Not with the reference of group G, migrating group Galu. We are taking the reference of geometry of phi system. Whether the group is arranging bottom of the phi system or whether the group is arranging above the phi system. That means phi system is the reference. That phi system is the planar. Suppose whenever the group is before going to migrate, that migration origin, it is existing in the below the plane. After migration, it is involving I comma j shift. It is migrating from one migration origin to its migration terminus. At the migration terminus, it may occupy the bottom of the face or above the plane. It may be occupy the below the plane or above the plane positions. If it is occupying the above the plane, it is different from the original migration origin position. Therefore, the opposite sides are there when we compare to the migration origin and migration termini. Then that kind of shifting is called as anterofacial migration. Suppose the group is attached at migration origin's bottom. After migration also, it is attached at the migration terminus is also bottom. Therefore, that kind of migration is known as suprafacial migration. For example, here I am taking orbital structure for your kind understanding. Uh, this is the system, generalized phi system. Now, the migrating group may be attached like this. Is the A and B, suppose. It is the attached migrating group. It is the migration terminus. X and Y migration termini. Sorry, migration termini. It is the migration origin. Right. At the transition state, at the in between the reaction, this migrating group partially attached with the migration origin, partially attached with the migration terminus. After migration, after complete migration, it moving in two directions. The group G is here, X and Y, A and B, and here is the phi system. X, Y, A, B. Right, this is also phi system. Now look at here. This is the group. When you compare that, it is arranged at the bottom. Once it is migrated, it reaches to the same bottom, but at different place. Therefore, this is known as suprafacial shift. Right. When it is reached above the plane, when we compare to the migration origin, now this is known as anterofacial shift. Based on this, sigmatropic reaction shows if a sigmatropic shift involves an achiral group, that G may be achiral group. That means you can take the methyl, ethyl, propyl, all these are achiral group. Or an atom like hydrogen, deuterium, or halogens like chlorine, bromine are involved. It shows two stereochemical modes. Two stereochemical modes. One is I comma j shift of I comma j, just I comma j suprafacial sigmatropic shift of a group G. The G may be a chiral group, maybe hydrogen, maybe deuterium, maybe halogen, or maybe a methyl group, ethyl group, isopropyl group, whatever it may be. It is a chiral, right? Next, the second stereochemical mode, I comma J anterofacial shift of anterofacial sigmatropic shift. We can also call anterofacial shift or shift means sigmatropic shift, right? Anterofacial sigmatropic shift of a G, right? R. Second one. For this purpose, I'm taking one example. 1 comma 3, 1 comma 3 sigmatropic shift of hydrogen. 1 comma 3 sigmatropic shift of hydrogen. This is the pi system. You can take here. Here I'm going to take ethyl, methyl. The CH3 is here, and some uh, is here, and one hydrogen is here. Now it is involving migration one, and both the sigma bonds ends are labeled with one and one, and extend the numbering in pi system 1, 2, 3. Then we maybe provide the thermology or photochemical energy, right? Right. Now this is hydrogen, CH3, and this hydrogen is migrating to this position, ethyl group, and here the methyl group is here. The double bond is shifted to here. Okay, this is known as 1 comma 3 sigma 2 shift of hydrogen. Right. Why it is become this is 1 as per our previous number 1, 2, 3. Now this is the I value, this is the J value. I comma J. 1 comma 3 sigma tropic shift. There. The first one stereochemical mode is 1 comma 3 sigma suprafacial sigmatropic sigmatropic shift of hydrogen. Sigmatropic shift of hydrogen. Same molecule, you can take it. That is hydrogen, the methyl, hydrogen, and ethyl, and methyl, which is I'm converting into orbital structure. Right. CH3. Just need to finish it now. Right. Then this is the ethyl and the methyl. Now this hydrogen is undergoing migration. This hydrogen is undergoing migration at the transition state. At the transition state. This is the hydrogen. Hydrogen and CH3, ethyl and methyl, which is partially attached with the migration origin. This is the migration origin. And also partially attached with the migration origin. Migration terminals. This is the transition state. After complete migration, what's happening? Right. Okay, it is not recovered here. Okay. Structure. Frequently it is stuck here. Okay. Again I'm redrawing. Okay. No problem. Yes, at the migration position, this is the methyl here. This is the ethyl here, and hydrogen and CH3. This is the hydrogen. Picture hydrogen CH3 is the methyl group, sorry. Methyl and ethyl and hydrogen is here. Then look at here. It is the hydrogen is traveling. The hydrogen is traveling across the phi system with the same side with the, look at here. This is the hydrogen. It is attached with the bottommost lobe. It is traveling across with the phi system and reaches to the migration terminal and attached to the lobe, which is same side with the lobe of phi system with the migration arching. Therefore, this is known as suprafacial migration. Suprafacial migration. Now, when you come into the second one, second stereochemical mode, 1 comma 3 antrafacial shift of hydrogen. You can write it also antrafacial sigma-tropic shift of hydrogen. Okay. Directly I am taking transition state only. No need to draw anything. Yes. This is the G group hydrogen is migrating. The ethyl fusion and hydrogen and CH3. Right. Sorry, it is methyl. Okay. Now it is partially attached with the migration origin, but it is migrated to the antrafacial. With respect to the pi system, this is antrafacial. Antrafacial migration. Why it is antrafacial? That migration origin, the bottommost lobe is interacting with migrating group. At migration termini, the above lobe, opposite lobe to the lobe which is present at migration origin is involved in the interaction. Therefore, these two lobes are opposite lobes are involved in the bonding interaction with the migrating group at the in the transition state. Therefore, that with respect to that phi system, this is antrafacial migration. After migration, you can obtain the product is like this. Product is like this: ethyl group, methyl group, hydrogen, and CH3. Then you can write the product like this: hydrogen, methyl group, and ethyl group. This becomes hydrogen. Look at here. When you compare it here, in the starting material, the hydrogen is in the bottom of the plane of the phi system. After migration, it reaches to the above the plane of phi system. This is known as antrafacial shift. This is known as antrafacial shift. Right. the extension to the stereochemistry of the sigmatropic reaction. Suppose if the migrating group is chiral group, where it shows four stereochemical modes. Four stereochemical modes. One is suprafacial shift of a chiral group with the retention configuration. Retention retention configuration. And the second one, suprafacial shift of a chiral group with inversion configuration. With inversion configuration. Third one, andrafacial shift of a group or of a chiral group with the retention, sorry, T it is, retention configuration. Retention configuration. The fourth one is same antrafacial shift of a group with inversion configuration. Inversion configuration. These four stereochemical modes are shown by the sigmatropic reaction when it is involving shift of a chiral group. Shift of a chiral group. Okay. I think next class time aitundi. Take some 10 minutes lunch time. You can join to the physical class. Okay. Today now I'm closing the session. If any class is there, other extension class is there, I will inform you. Okay. Thank you.
ఓకే సార్ రిజల్ట్ ఎప్పుడు సార్?
Right.
సార్ గుడ్ ఆఫ్టర్నూన్ సార్.
Can you repeat please?
సార్ ఫస్ట్ సెమ్ రిజల్ట్ ఎప్పుడు ఉంటుంది సార్?
ఫస్ట్ సెమ్ రిజల్ట్స్ ఇంకా వాల్యుయేషన్ కంప్లీట్ ఇవ్వలేదు బాబు. మీదైంది కానీ మిగతా సబ్జెక్టులు కూడా కావాలి కదా.
అవును సార్.
అవి వెయిటింగ్ అవుతుంది.
Okay, sir.
ఇస్తారు నాకు తెలిసి 1 week 10 days లో వచ్చేస్తాయి.
ఓకే సార్. ఈ ప్రాక్టికల్స్ ఎప్పుడు ఉంటాయి సార్? ఫస్ట్ సెకండ్ సెమ్
ప్రాక్టికల్స్ మేము వీకెండ్స్ ప్లాన్ చేసినాము. ఇంకా అప్రూవల్ పంపించినాము. పై నుంచి అప్రూవల్ రాగానే మీకు డేట్స్ ఇన్ఫార్మ్ చేస్తాం. Friday, Saturday, Sunday, 4 weeks.
ఓకే సార్. ఓకే.
Not just like previously we are planning for continuously 12 days. I think most of them feel difficulty to take the leaves.
సార్ అవును సార్.
That's why we are planning weekends, Friday, Saturday, Sunday for 4 weeks.
ఓకే సార్.
I think it is most of them are agreed. One
Okay,
Sunday
sir.
will be helpful to you from the leaves, I think.
ఎస్ సార్.
Right.
సార్ మెయిన్ ఎగ్జామ్స్ సార్ సెకండ్ సెమ్ ఎగ్జామ్స్ ఎప్పుడు ఉంటాయి సార్?
Second sem exam in the month of September, 3rd week.
సెప్టెంబర్. ఓకే.
Yes.
థ్యాంక్ యూ.
Okay, thank you.
థ్యాంక్ యూ.
Any doubts? Actually, it is this class will be in the physical form very helpful to you, but the offline mode అయితే బాగుండేది క్లాస్ కి, ఈ సెషన్స్ కి. I mean, especially topic కి. And okay, we'll cover it, no problem. Okay.
ఓకే సార్. థ్యాంక్ యూ సార్.
Right. If you have any problem, I will repeat again. No problem with that.
నో ప్రాబ్లం సార్. ఇంపార్టెంట్ క్వశ్చన్ షేర్ చేయండి సార్, చదువుకుంటూ స్టార్ట్ చేస్తాను.
ఇస్తాను.
ఓకే, థ్యాంక్ యూ.
Right. మీకోసమే ఆన్లైన్లో పెడుతున్నారు. మీరేం చాలా తక్కువ మంది జాయిన్ అవుతున్నారు. 6 మెంబర్స్ కోసం ఏదో ఆఫ్లైన్కి రమ్మంటే బాగుండేది. ఆఫ్లైన్లో 15 మంది 20 మంది ఉంటున్నారు క్లాసెస్కి. మీకు ఇంటి దగ్గర సండే రోజు క్లాస్ పెట్టినా కూడా ఇది అసలు ఏమీ ఉపయోగం లేకుండా పోతుంది.